Hello, in this video I'm going to talk about pendulums and just a couple of factors that you need to take into account when looking at how pendulums swing. So a simple example of a pendulum is just a weight or a mass on the end of a string, and you can imagine that if you pull it over to one end, you could let it go and then this pendulum would swing. So it would go from one point to the other and then back again. Now there's a special name for the time taken for it to do that, and that is called the period, and it's denoted or shown by the letter capital T, and the period is the time taken for one complete cycle. Now by one complete cycle we mean the time taken to go from one end to the other and back again. That's very important that you measure all the way there and all the way back to get the correct value for the period, and that's time, so it's measured in seconds. The other formula that you need to know, or the other equation that you need to know, is the time period is equal to 1 divided by f, where f is the frequency. So in other words, f is how many cycles per second. So if you know the number of cycles per second, you can work out the frequency. So imagine the frequency was 0.5. The time period based on that would then be 1 over 0.5 equals 2 seconds. Okay, so that's just a quick way of, or a quick example of using that particular formula. Now, one thing about pendulums is they are a good source for how science works types of questions. So if you look here, I've got a table. We're looking at the length of a pendulum versus the mean periodic time, and here I've got some readings that I've taken. So time for one period, and remember period is time taken to go from one end to the other and back again. So I've got 3 readings, repeated it 3 times, and I've taken a mean. So you can imagine in the exam they might leave one out and ask you to calculate the mean periodic time for one particular one. And then you could go ahead and do that, because calculating the mean is one of the things that's actually mentioned in the spec. You could also look for any errors that might have happened in this set of results, and if you look over here, we've got a reading that's not close to the other two. So we've got 4.2, 4.2 and 2.1, so we can say that's anomalous. It's a word that's often used, anomalous, and that means a reading that doesn't or is not close to the other readings in the set. And the exam question might ask you what to do or what's been done about that. You can either ignore it and calculate the mean from the remaining numbers, or what you might do if you're doing the experiment is you might just repeat one. Another type of question might be, what's the likely error that the students made in this measurement here? Well, if you look, the time for one period is 4.2. This reading they've taken is 2.1. So what they might have done is actually just measured half a period. In other words, the time taken to go from one end to the other. So that's a possible error that could have been made there. There's a relationship between the length of the pendulum and the mean periodic time, and this is important for you to know as well. The longer the pendulum, the longer the mean periodic time, or the mean period we could say as well. The longer it takes to go from one end to the other. Incidentally, the mass on the pendulum has no effect, so you could double the mass and that would still give you the same set of readings that we have here. The only other thing that the spec says is that the examples I'll give you will be things like playground or fairground rides. So here's just a quick example of a couple of questions. We've got a fairground ride that takes 4 seconds to go from the highest end at one point to the highest end at the other, and the first question says, what is the period of the ride? Well, if we just take any point, let's take a point over here. It takes 4 seconds to go from here to the other side, but remember the period is the time taken to go from there to the other end and back again. So the answer for this would actually be 8 seconds. Calculate the frequency of the ride. Now this is slightly more tricky, because our formula, remember from our previous page, is the period is 1 over f, so we would require to, or we are required to rearrange that, and you can do that by just remembering this formula triangle if you're not very good at rearranging. But if you look, the frequency, this is the one we want, frequency here, so the frequency is 1 divided by t, and we now know that t is 8, so frequency is 1 over t, and that would be 1 over 8, and I believe that is 0.125, and its frequency, so it's cycles per second. And you may remember from previous videos that cycles per second is another way, or another way of saying that is hertz. So the frequency there would be 0.125 hertz. And the last question here says a second version is made, of the ride. The makers want more thrills and want the period to be longer. What factor should they change? So something else that you need to also know is, or sorry, we've also mentioned, is that the longer the pendulum, the longer the period. So the factor that they should change is the length of the supports or the bars, or the pendulum, I suppose you could call it, pendulum. Okay, so that's what the factor they could change to make that ride or the period longer. Okay, so that's just a quick overview of pendulums and the kinds of things that you should really know about them.